Hello everyone, myself Ankur Patel, and today in this second session of section of solid we will continue our practice with problems of section of solid. In the last session we have discussed an example in which we have taken auxiliary inclined plane as a section plane, and today we are going to discuss an example in which we will take auxiliary vertical plane as a section plane. So before starting example, let us discuss about auxiliary vertical plane. Auxiliary vertical plane. So what is auxiliary vertical plane? A cutting plane which is perpendicular to the horizontal plane and inclined to the vertical plane is known as the auxiliary vertical plane. And if the solid is cut by using the auxiliary vertical plane, then the cutting plane line is drawn in the top view, which is inclined at an angle of phi with the vertical plane or xy reference line. So here you can see that we have taken the cutting plane line in the top view, inclined at an angle of phi to the xy reference line, and apparent section appears in the front view. So the section appears in the front view is known as the apparent section. And again the true shape of the section is drawn separately. So the true shape of the section will be in the plane which is parallel to the cutting plane. So now let's try to solve the examples of section of solid by using all this information. A hexagonal pyramid of base side 30 mm and axis 70 mm is resting on HP with its base on it, and one of the side of the base is parallel to VP. The axis of the pyramid is 40 mm away from the vertical plane. The pyramid is cut by the AVP inclined at 30 degree. The cutting plane is 15 mm away from the axis and nearer to the observer. Draw the top view, sectional front view and true shape of the section. So first of all, draw XY reference line. Now here it is given that a hexagonal pyramid of base 30 mm, axis 70 mm is resting on HP. It is resting on HP with its base on it. That means the base of this hexagonal pyramid is on the horizontal plane, and one of the side of the base is parallel to VP. So if the base of this hexagonal pyramid is on HP, the top view of the hexagonal pyramid will be the true shape of its base, and it will be a hexagon. And we have to take one of the side of the base parallel to VP. That means as we have drawn the top view, for the top view the XY line will be our vertical plane. So now we have to draw the top view by taking one of the side of the base parallel to the XY reference line. So top view of the hexagonal pyramid will be the true shape of its base, and it will be a hexagon. And so we have to draw the hexagon by taking one of the side parallel to the XY reference line. The axis of the hexagonal pyramid will be 40 mm away from the vertical plane, that means 40 mm away from the XY reference line. The side of the base is 30 mm. So this will be the top view of the hexagonal pyramid. A, B, C, D, E, F and O. That means A, B, B, C, C, D, D, E, E, F and F, A are the top view of the base edge. OA, OB, OC, OD, OE, OF are the top view of the slant edge. Now we have to draw the front view, and as we have discussed, the front view of the the front view of the pyramid will be a triangle. So project all these points vertically upwards. Mark this point. This is A dash, this will be our B dash F dash, this will be our C dash E dash, and this will be our D dash. So mark these points and draw the base. This will be the elevation of the base. Now we have to draw the front view after drawing the base. So first of all project these points vertically upwards and measure the axis height, which is 70 mm. So here we will get O dash will be the front view of the apex point. Now connect apex point to the base corners, that means O dash to A dash, O dash to F dash B dash, O dash to C dash E dash, and O dash to A dash will be the front view of the hexagonal pyramid. Now here there isn't any need to draw the side view of the pyramid, because here we have to draw the front view and the true shape of the section, and we have to draw the top view only. So we will get the section in the front view. We will show the cutting plane in the top view, because here it is given that the pyramid is cut by AVP. So if we have AVP, that is the cutting plane which is perpendicular to the horizontal plane, inclined at an angle of 30 degree to the vertical plane. So we will show the cutting plane in the plan, and the condition of the cutting plane is given. It is inclined at an angle of 30 degree to the vertical plane, that means 30 degree to the XY reference line, and the cutting plane is 50 mm away from the axis. So right now we have shown the cutting plane in the plan, and it will be 15 mm away from the axis and nearer to the observer. So first of all, what we have to do, we have to draw a line inclined at an angle of 30 degree from the apex point, or from the top view of the apex point. So draw a line inclined at an angle of 30 degree. Now our cutting plane is 15 mm away from the axis, and it is nearer to the observer. So if we are observing the front view, the observer will be over here. So we have to show the cutting plane nearer to the observer and 15 mm away from the cutting plane. So now measure 15 mm perpendicular distance from this line, and draw a line parallel to this line from this point. So this will be our cutting plane, which will be inclined at an angle of 30 degree to the vertical plane, that means 30 degree to the XY reference line, and 15 mm away from the axis. So this will be our top view of the axis, and cutting plane is 15 mm away from the axis. So we have shown the cutting plane, and it is nearer to the observer, it is not away from the observer. Now after drawing the cutting plane, we have to remove the part in between the cutting plane and the observer. So we will remove this part. So this part will be our section of the solid that we have to show dark. Now we have to show the section in the front view. So for that we have to project the intersection point of the cutting plane to the top view. So the cutting plane is intersecting over here at point B, over here and over here. So we have to project all these 3 points, 1, 2, 3 in the front view. So project this point, will cut the front view at the base at B dash or F dash. So project this point over here. So this will be our first point. Now this point will be projected on the slant edge OC in the front view. So on the slant edge O dash C dash, we have to project this point up to the slant edge O dash C dash, because this intersection of the cutting plane is on the slant edge OC. So we have to project it up to the slant edge OC over here, and this intersection point is at D dash. So project this point up to D dash. So now this point 1 dash, this is 2 dash, this is 3 dash. Now as this point is 1 dash, 2 dash, 3 dash, this point will be our 1, this will be 2, and this will be third point. So connect this point 1, 2, 2, 3 and 3, 1. This will be the section in the front view, and as we have removed this part, the backside part will be visible in the front view also. So draw it dark and show the cutting plane lines or hatching lines in the front view of the section. So draw the hatching line in the section, and hatching line will be inclined at an angle of 45 degree to the XY reference line, and the minimum distance between two hatching line will be 2 mm to 3 mm. Now we have to draw the true shape of the section. So as we have discussed, the true shape of the section will be in the plane which is parallel to the cutting plane. So now we have to draw a line which is parallel to the cutting plane over here. This will be our section front view. So we have to draw a line parallel to the cutting plane line, which will be our x2, y2. Now we have to project 1, 2, 3 perpendicular to the x2, y2 line. So draw the projections from 1, 2 and 3 perpendicular to the x2, y2 line. This will be the projector of 1, projector of 2, projector of 3. Now what we have to do? We have to measure the points of the section from the intersection point of the projection of 1, 2, 3 to the XY reference line. So follow the projector of 1, and from the intersection point of this projector to the XY reference line, we have to measure the point of the section. So right now we have 1 dash on the XY reference line, so we will get the 1 over here in the true shape on the X2 Y2 line. Now follow the projector of 2, and from the intersection point of this projector to the XY reference line, measure the second point, that means measure 2 dash from this point, intersection point of the projector to the XY reference line, measure 2 dash, put your rounder over here and give an arc over here to mark 2 second point, and we will get the 3 on the XY reference line. So here we will get the 3 on the X2 Y2 line. So mark 3, connect 1 2 2 3. This will be our true shape of the section. So we have to complete the true shape of the section by drawing the hatching line, incline at an angle of 45 degrees to the X2 Y2 line. So this will be our true shape of the section. So this will be our final sectional front view, top view and true shape of the section that we have to draw in the given problem. So this is it for today. Thank you for watching. See you in the next lecture. Till then, take care.